Okay, so now maybe it'll come through. Okay, so now maybe it'll come. Yep, there we go. All right, so I was streaming games on here the other day, and so it was trying to pick up the Elgato instead of picking up the Blue Snowball. So let me turn down my phone, which is how I check the stream. And we'll go from there. So I've got my iPad ready to go, and I've got some problem sets, and I've got the calculator. So let me backtrack a little bit. There we go. Okay, and sound effects should be on as well. Let me troubleshoot this since it doesn't look like anybody's on yet. Yeah, I think it's just me that signed in. So I got a few minutes just to troubleshoot, tinker just a little bit. So I'll continue to charge my Apple Pencil. And let me go into my settings. Oops. It's really echoing off. I'm sorry about that. So trying to figure out why it is not playing. I don't see anything on here. All right, and again, I'm just sitting here for a few minutes waiting for students, but while I'm doing that, I'm troubleshooting my sound. Ay. Doesn't make sense. I'm going to pull this out. This groove should be okay. don't know why it's going on like that. I've got a down thumb. That's great. Thanks for stopping by. Not sure why that is. I'm just waiting for students. Hey, what's up, Amari? Somebody gave me a thumbs up and a thumbs down. Yeah, semester's going pretty good. Hope it's going good for you. Yep, one more week next Wednesday. Hope things are going good for you. And appreciate you stopping by. Again, I just looked up on the YouTube side of the house. Got a thumbs up and a thumbs down. So basically, I'm just troubleshooting through my audio, just trying to figure out why the background's not playing. So if folks are disappointed, I'm sorry. Just waiting on folks to come on. But I can't seem to get that up, so I think I'm just going to leave it for now. So if folks are just... I will try it again later. So yeah, Mars, thanks for stopping by. I appreciate it. So let's do a little something here, and let me just pull up my... Yeah, it's a different look. I've had it for a little while now, but not too long. So, wow, I just deleted out that, so let me go back. Yep, there it goes. Okay. Yeah, the beard's a little bit different look, but I told the wife until I get back in shape, I'm just going to leave it. So, might be a little while. Okay, so let me get started. Let me just test my screen here. Find out where I'm at. That's interesting. So if I type here, I'm okay. Good. Just want to see what half of my screen was in place. So we're going to work with a binomial real quick. So let's take a look. We worked with this last night, and I just want to go back through it on the calculator. So if you remember, if we have a binomial, we're going to know. Oops. We're going to want to know how many trials there are as a binomial distribution, so it's going to be a fixed number of trials. The probability of success, which is going to be P. The probability of failure, which is going to be Q. And then you'll already have identified, as far as what you need to find the calculations, this is what we're looking at. And you should have already identified, or somebody should have identified for you, in the context of the problem, what the value of the random variable x represents. So in this case, let's say that we've got one where the fixed number of trials is 8, and the probability of success is 0.37. And that leaves us with what? 0.63 left. So the probability of failure is 0.63. The probability of success is 0.37. N equals 8. So when you are looking at using the calculator, we're just going to go to second vars. It's going to bring up this menu. Now, this particular calculator is the best working one I've got. It cost me about $4.50 on Apple. But it's got all the same features, but it's slightly different looking. So when you hit second vars on your calculator, it will look just slightly different than this, but it's the same in reality. If you go all the way down, scroll on your part till you get to Binom PDF, this is what we're going to work with. And so you've got Binom PDF, and our syntax for this, as I've shown you in class back when we were covering this, and also last night when we were reviewing, is NPX. In other words, in the case of our example here, we're going to be Binom PDF, probability density function. Our N is going to be 8. The probability of success is going to be 0.37. And your probability of failure is going to be, the value that we're trying to find in this case is going to be 0. So if we're building a probability distribution, make sure I don't run out of room here. If we're building this, then we would have, man, why did I make it 8? I'm going to back that off. I'm going to change it. There we go. Well, let's make it 4. The reason I'm doing this is because I may run out of room on this particular truncated screen. So the possibilities for your binomial distribution, in other words, what the random variable x can be, is any number 0 through 4. So whatever the context of the experiment is you're doing, or situation that you're looking at, the possible values of the random variable x are 0, 1, 2, 3, 4. So we want to find these probabilities. So we don't know what these are, and that's what we're going to find out. So if I go back to the calculator and I go binom 4, comma, then our probability was of success was 0.37, comma, and I go 0 and hit enter, then I'm looking at, we'll go 4 places, 1575. So you're looking at 0.1575. If I hit second enter, should bring it up again. I backspace twice. Whoops. And I type in a 1, and I've got 0.3701. That probability. And I still ran out of room. I noticed that right here. But if I go through a couple of these, I think we'll be okay for this example. If I go back, type in a 2, hit enter, 3260, and so on. So I can find 3 and 4 as well. So I'll finish out with 3, even though my head's in the way of this one. 1276. There you go. And then 4 would be what it is, but you can't see it on the screen. So what I'm doing here is just building a binomial distribution table using the calculator, same as we went through in class. If I was not using the calculator, then I would approach it in a little bit different manner. In other words, you may have a problem on the final where I ask you to show the work as you find one of these, the probabilities for one of these possibilities for the random variable x. So go away from the calculator for just a second, and I still want to build this. And I'll look at this one right here. Let's go. I'll look at 2. So I want to find what the value of the what the probability value is for 2. So if I go second enter, scroll backwards, I already know what the answer is, right? It's 3260. So I took everything off, and I'm going to put this one back on there. 3260. Right? Now, in order to find this, if you had to show your calculations for this, in order to show what the calculations would be, there's a form that we used. Actually, I'm going to use this. Let me change colors. Dark green. So we're going to use the probability that we have 0, and I'm going to run out of room, so I got to take that off. Backtrack a little bit. Probability of getting 0 successes in 4 trials of whatever the context of this is. So just like in the review last night, we've got n factorial on top, n minus x factorial on the bottom, times x factorial, little x just to represent time, so we've got times probability of success to the x value times probability of not success to the n minus x value. So, gosh knows, man. I'm sorry. I'm going at 43763. So we've got n equals 4, p equals 0.37, q equals 0.63. So I'm just going to write those over the side. Now I'm going to go back and write this again. I apologize for my cutoff screen. I haven't posted it. I haven't done a live in a little while, so getting back into the swing of things with Ecamm. Back to this. So the probability of 0 is going to be n factorial over n minus x factorial times x factorial times, not x but times, probability of success to the x value times the probability of not success to the n minus x value. So there's what we're working with. So I'm just going to substitute in down here just below it. So what was n? Well, n was 4, so we've got 4 factorial, 4 times 3 times 2 times 1. On the bottom here, I've got n minus x. So 4 minus 2 in this case, so we're trying to verify what the calculator got. And I'm just showing you how to work through this using the calculations as we did in class. So I've got 4 minus 2 is 2. So I got 2 factorial, so I got 2 times 1. And then the x is 2, so I've got 2 times 1. Becomes 1, so it's gone. So I'm left on the top with 4 times 3 is 12, divided by 2, so I just got a 6 there. So let me extend this, times the probability of success, which was 0.37, to the x value, which was 2, times 0.63, to really whatever's left. And we had 4 trials here, so it's going to be n minus x, which again is 2. N was 4, x was 2, so there we go. So there, now I can see it. Okay, so there we go. So one more down, and I've got basically this right here is 12. So I've got 12 divided by 2 times 0.37 squared times 0.67 squared, and I end up with something. Let's see what I end up with. So I got 6 times 0.37 squared times should be 6.3. Glad I caught that. Here we go. 0.63 squared. So now 0.63 squared. And there it is. 0.32601366. And it matches what we had done at the bottom. So I got 0.3260 basically, which matches that from the calculator. So anyway, on the test, remember we went over this again last night, but we certainly covered it in detail throughout the semester. But if you were given a problem where you need to show how to find, through computation, the probability of the value of the random variable x being 0 or 1, 2, 3, then you could find it. And I actually made a mistake there too. I said 0, but I really worked with 2. So I had all the numbers right all the way down. There we go. Okay. And it's 3260. So I did all the computations right. I got the same thing as what the calculator spit out. So there we are. Okay. And moving on. So there is an example of a binomial. Let's clear this out, erase all strokes, and let's go back to a different page. Let's go back to where I don't think I have it on there. Let's go to my problem sets. Let's talk about this. This is your take-home exam practice problem set, due, by the way, on the night of testing. So don't forget to bring this back in. Oops, I didn't mean to make that bigger. Boy, oh boy. Okay. So they're messing around with it, like with the mouse instead of interacting with it. Okay, so these are the problem sets that we're looking at. This is what I gave you. It is due back next Wednesday night. These are the problems that I wanted to look at tonight. I'm not necessarily going to grab any. Maybe I'll grab 1 or 2 here Just real quick, I think what I'll do is I'll look at number 6, but I am waiting for folks to show up. This is a 5-point extra for your test, for your final exam. It also gives you an opportunity to ask me questions on this if you've had a chance to look at them. I posted it last week to the Moodle, and I handed it out last night, paper copies. So I'm still blown away. Somebody popped in here and just gave me a thumbs down when I was getting things set up. That's so mean. No problem. All right. So let's look at this one right here. I'm going to write the numbers and I'll come back to it because I'm going to use my workspace. So I've got find the 5-number summary of the set of numbers before. Okay. So I've got 4, 4, 5, 6, 9, 3, 6, 6, 9, 1, 5, 9, 3, 5. Okay. Let me write those numbers up here. You can't see me writing them, but I'm going to come back to this. 4, 4, 5, 6, 9, 3, 6, 6, 9, 1, 5, 9, 3, 5, 15, 38, and 4. Okay, find the 5-number summary. So let me pop back to the workspace. There we go. So I've got them up here. I crammed them at the top because I was afraid to run out of room. So we need to find the 5-number summary, okay? Five-number summary of these numbers above. These are the ones right from the work page that I gave you. So in order to find the median and to find the median of the lower half, meaning the upper half, which is Q1 and Q3, and the min and the max, I need to put these in order. It was 1538.4, so I probably need to underline that before I forget it. 1538, that's 2-digit numbers. Those are the only 2 digits, okay. Let's put them in order. So I've got the lowest number, which is 3, and then another 3, and then I've got 1, 3, 3. Then I've got 4, 4, 4. Then I've got 5, 5, 5. I don't have a, yeah, I got 6, 6. Oh, 3, 6 is not good. When I made that up, I wasn't planning on it working out like that. Then I've got 9, 9, and 9. It's everything that way. Then I've got 15 and 38. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Okay, we're good. So I've got them in order, so now I can very easily find the lowest number, which is the min. Which is 1. I can also easily find the max. Which is at 38. So I got 1 and 38. No problem there. The median is going to be the middle number. So I'm just going to count backwards. 1, 2, 3. Is it 5? Yeah, it is. So the median is 5. Yeah, 17. So 17 numbers. Now I need to find Q2 and Q3. Well, while I'm looking at the set, all I need to do here is find the median of the lower half, the lower 50%, and the median of the upper half. The median of the lower half gives me the Q1. The median of the upper half gives me the Q3. So I'm going to count back. 1. It's these two numbers. And the average of those two numbers, 4 plus 4 divided by 2, is going to be 4. So I've simply got a 4 down here. On the upper end, I've got here, 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 and these two. So same thing there. 9. So there it is. So I'm looking at one. Oh, well, you can't see the max, but the max is 38 because I forgot my head's down in that lower corner. I try to minimize down there at the bottom just so I'm just barely in the picture. But every once in a while I forget what's beneath me there, where I'm working at. So that's it. The min is 1, Q1 is 4, median is 5, 9, and 38. Now, the next question let's look at is, are there any outliers? And we're going to use Tukey's method. In my class, that's what I've stayed with, is Tukey's method for finding outliers for a given set. I need to find the interquartile range, the IQR, which is just that middle 50%. It's the Q3 subtract the Q1. And if any of you have never been through this and you come on here and you see this, not rocket science necessarily, but if you've never seen it, you might be going, wow, he's going really fast. But this is a review for the final. So I'm just kind of reviewing over stuff that we've already covered in vast detail. So Q3 is 9, Q1 is 4, 9 minus 4 is 5. So there's the IQR. Now I take 1.5 times that 5, and just to stay accurate, I can go 1.5 times 5, and I get 7.5. So Tukey's method says that I do 1.5 times the interquartile range, always 1.5 times whatever the interquartile range is, and then I take that number that I get, that 7.5, and I subtract it from Q1. Anything outside of that's an outlier, and I add it to Q3. Anything outside of that is an outlier. So I know that 7.5 is what I'm working with here, so I can take this off actually. So I have a little bit of room. So I've got Q1 subtract 7.5, and I've got Q3 plus 7.5. So, well, this is going to be a negative number, right? So I've got 4 subtract 7.5. I don't really need to walk through that. It's going to be a negative number, so it's going to fall below our set. We don't have any negative numbers in this set, so there are no outliers on the low end. Now Q3, which is 9 plus 7.5, and just to say, 9 plus 7.5, let's stay accurate, use a calculator, 16.5. Anything outside of 16.5 is an outlier. So per how we worked outliers in class using Tukey's method, the outlier here is 38. So you have one outlier, and that's it. All right. I would say, are there any questions, but I have nobody. I don't think anybody from class on. It looks like there's a person on, but nobody has identified themselves. So if you're in my class, you can give me your initials. You can give me where you sit in class and initials, however you want to put it, and I'll know who you are. You don't have to give a full name or anything. But now I am back looking at the take-home. And let's scroll down. I think I'll do one more unless I hear from somebody, because we are looking at it is 7:36, so I've been on about half an hour with nobody showing up, which is okay. No offense taken. Still have that thumbs down. Boo. Let's look at number 12. Find the mean, variance, and standard deviation of the binomial distribution with the given values of n and p. N equals 79, p equals 0.62. So I'll write those values up here. So So N equals 79. P equals 0.62. And I'm looking to find the mean, the variance, and the standard deviation. Okay. So I've got my numbers transcribed over. Let me go back. For some reason my Stream Deck's not working, so it'll take me a second. All right. So in order to find the mean of a binomial distribution, that's what we're working with. Find the mean, variance, standard deviation of the binomial distribution with the given values of N and P. Okay. So I'm working with a binomial. The mean of a binomial equals N times P. So if I just take 79 times 0.62, I get 48.98. All right, no problem. The variance of a binomial distribution, these are discrete distributions, discrete probability distributions that we're working with, and the variance of a binomial is just simply going to be NPQ. So whatever I got before, 48.98, I'm now going to multiply times the probability of failure, which if the probability of success is 0.62, you're 728292, you're looking at 0.38. So I just say this times 0.38, 18.61. And the same mathematical relationship exists between the variance and the standard deviation here. And the standard deviation is the square root of 18.61. So really, it's that. There it goes. And then the second square root of 18.61. 4.31. There's that, there's that, there's that. So that's it for that particular one. So that's for the binomial distribution now. Since nobody's on to ask questions, I'm not necessarily going to work into a regular discrete, but define the mean, the variance, standard deviation of a regular discrete probability distribution is not the same forms. So make sure on your 3x5 index card, if you need to remember that, you write that on there and be sure you're able to work with it. We worked with those quite a bit on the calculator. With using columns to represent parts and pieces of the mean, variance, and standard deviation. All right, we are 40 minutes into it. I took a few minutes at the beginning and wasn't doing much of anything except setting up my stream and wondering why the background music wasn't in there. I'll go back and work on that after the fact. But I thank anybody that stopped by. Even the person that gave me a thumbs down. Thank you for stopping by at least saying hi. But hopefully you'll be able to review this video, and if you have any questions on it, send me an email. I'll be glad to get back with you on that. And then we will be in the final. We will take our final next Wednesday at 5 o'clock. If you're not able to be there at 5, I'll also be there at 6 o'clock during our regular meeting time. But you're more than welcome to come at 5 o'clock next Wednesday and start the final early. So that is all I've got. And I want to thank you for coming by and appreciate that.